Okay, everybody, we're going to be looking at a quick video, hopefully, on determining the number of solutions to a system of equations. When we talk about a central question, basically, what is a system of equations? What does it mean to be a solution to a system of equations? And what are the possible number of solutions to a system? So first of all, in order to do this, we need to know how to find slope and y-intercept in both forms. So we're going to do a quick review. First of all, in slope-intercept form, it's really easy because it's called slope-intercept. That's the slope, and that's the y-intercept. So it's very, very simple in slope-intercept form. In standard form, it's a little bit more complicated. Now to graph it, we start with the y-intercept. We do rise over run, up 2 over 1, and we graph our line. And that's it. Okay? What I want you to think about is two things. Okay, this right here is basically the tilt of the line. So how, when you talk about if it's positive, negative, if it's steep, if it's not, it's basically what the slope does is it determines how tilted the line is. Okay, the y-intercept is basically where it is. Okay, so it's the location. So where is the line? Okay, because if I take this same line with a tilt of 2 and I start here, okay, I'm going to get a very similar line. It's going to look the same tilt, but it would have a different location. I could also have a line that had the same location, started off in the same place, right there, but the slope was completely different. That would result in a line that has the same starting place, same location, but totally different tilt. And depending on these two things, the tilt of the line and where it starts, those are going to determine all three different possible kinds of numbers of solutions we can have. Okay, let's look at standard form next. Okay, standard form, remember, is when x and y are standing next to each other. That's why I call it standard form. Okay, in order to find it, we take the opposite of a. Remember, this is a, this is b, and this is c. We take the opposite of a, so that'd be -4, over b, which is +2. Okay, simplifying that, I get a slope of -2. Now to find the y-intercept, what we do is we actually plug in 0 for x and we solve the problem. Or another way we did it in class is we took this number right here, the -16, and we just divided it by that number right there. So we take -16 divided by 2 and get -8. To graph it then, we graph it the exact same way we did before. We start at -8. That's our starting point, or where the line goes. And our tilt is now up to left 1. Okay, so I want you to keep thinking about that tilt and thinking about that starting location, because those are very important. Those are really the only two things that make a line, is starting point and tilt, because that's all there is to it. It doesn't curve, it doesn't change. You have the starting point, you have the tilt, you have everything that makes a line. So thinking about that, if you have two lines that are the same, the only two things that make them special are their tilt and their location. So if they were the same line, they'd have to have the same tilt and the same location. So let's first look at the possibilities. So you could either have lines that cross one time like this, lines that cross no times like this, or lines that are basically one right on top of the other. If you're going to go ahead and explain to somebody in only terms of tilt and only terms of location, think about how you might explain each one of these situations. Okay? That's kind of how I want you to think about this, because at the end we're going to have rules, but those rules are only good if you can remember them. Okay, so instead of trying to memorize a chart, which we are going to look at a chart at the end, instead of trying to memorize that, try to think about tilt and location. So if I was going to describe this first example here, okay, I would say those two lines have different tilt, okay, and I can't really tell about the location, but I can tell that they cross right there, okay, but, without a chart, without a graph in here, maybe that's my y-axis. Now I know, oh, okay, they have different location. But really, the only thing I needed to know that they're going to cross one time is that they have different tilt. That different tilt creates it. Even if they're tilted the same way but just slightly different, they will eventually have to cross each other. So really, the only thing that was important there was, in fact, the tilt. If I was going to describe this second example to someone, how would you do that in terms of just tilt and location? And granted, we don't have a y-axis here. But I think it's safe to say those lines have the same tilt. That's what gives them that same parallel look, right? They have the same tilt, but they're in different places. Okay, so when we talk about y-intercept and slope, we're going to be talking about lines that have the same tilt in different locations. The third example, okay, down here, that's one line right on top of the other. So they have the same tilt, okay, because they're in the same, it's obviously one line right on top of the other, but they're also in the same place. So we have everything the same for those two lines. Remember, there's only two qualities that make someone. Imagine you had an identical twin. There's a, and even then with identical twins, there's differences that people can tell. But imagine if there was only two things for humans that made them special. Let's say height and, the way their face looked. That was it. Okay, let's say that was it. Identical twins would look truly identical if they had the exact same height and the exact same face. I mean, that would be it. You wouldn't be able to tell the difference. That's kind of how it is with lines. There's only two things that identify them. So when they have the same tilt and they have the same location, they're the same line. Those three situations and those three comparisons of tilt and location are all you need. Okay, so what we're going to do is we're going to look at examples. Okay, we're just going to take one example of each. Starting off here, what we're going to do is we're going to identify the slope and we're going to identify the y-intercept. That is our shortcut. We don't want to have to graph this. We will graph it so you can see what it looks like, but the idea here is to not need to graph. So first I'm going to look at the slope and the y-intercept. It's very easy on the first one. Slope is in front of x, y-intercept is the other one. Now I'm going to go to b. I'm going to go ahead and graph these really quick. Okay. Now I'm going to go ahead and go to the b. I'm going to take the opposite of a over b. So that's going to give me -4 over -2. Which gives me +2 over 1. What I have right now, remember this is my tilt, I have two lines that have the same tilt. Okay, when two lines have the same tilt, that's going to mean automatically that they're either going to be one line right on top of the other, or they're going to be one line and another line in different places, so they're parallel. Those are the only two things that can happen. As soon as I notice those tilts are the same, I've got the lines that are tilted. They can't possibly touch one time. They either have to touch no times or they touch all the time. Okay, taking the y-intercept, remember we're going to go ahead and we're going to take, in case you forgot, we're going to take this number here and divide it by that number there, including the negative sign. That's how I get my -4 down here. Graphing that, you're going to see I end up with two lines with the same tilt in different locations. Okay, so now ask yourself, how many solutions does this have? Remember, solutions is the number of times they cross. So how many times are these lines going to cross? Well, they're never going to cross, so there's no solution. But how can we know that without having to graph it? See, I don't want to have to do this. This picture is nice so I can understand it, but I don't want to have to do all that every single time. What I'm going to do is I'm going to look at these. I'm going to say, hey, the slope's the same. That means my lines are never going to touch one time. They're either going to always be touching or they're going to never touch. That's it. Okay, now I look at where they are. If I have two lines at the same tilt in different places, they're never going to touch. When I notice that those places are different, starting points are different, and they follow the same path, that means no solution. That's how you got to think about this. Okay, so now we're going to move on to a second example. Okay, we're going to take a look at this one. So again, my slope on the first one is -3. My y-intercept is -4. Very simple. Just take it straight from the problem. Graphing that, I'm going to start at -4. I'm going to go up 3 and left 1 and draw my line. Second one, remember, we're going to take opposite a over b, which is going to give me -6 over +2. That again gives me a slope of -3 over 1. Automatically, I have two lines with the same tilt. That tells me they're either going to be run parallel to each other or it's really the same line in disguise. Okay, now I'm going to do my y-intercept again. I'm going to take that number divided by +2, and that's going to give me -4. Okay, so now look what I have. I have two lines with the exact same tilt. Okay, talked about the tilt being right this. Okay, they have the same tilt. They're tilted the same way. So they're either going to never hit or they're always going to hit, but they're in the same place. Okay, so they're basically one line right on top of the other. Everything about these lines is the same. These are the only two things that make lines special. So when they're the same thing, just disguised in a costume, if you will. Okay, so now we have one right on top of the other. So we end up with the same line. A lot of times when you write this on paper, if you do have to graph it, I sometimes will put like a squiggly over top to show that there's two lines there. So if we talk about number of solutions, that means how many times these lines hit? Well, they always hit, infinitely many times. And so what we're looking for is every time we see two lines have the same slope and the same y-intercept, it's saying the lines are the same. Those are the only two things that make them special. If two lines have the same tilt but different y-intercepts, they're just the same line, but they're in different places. The same line in different places aren't going to hit each other because they do the same things. Okay, it's like you and a friend standing 5 feet apart from each other and walking step for step, 5 feet forward, 5 feet left, 5 feet forward, 5 feet left. You'll never run into each other. Okay, whereas if you started, right next to each other, let's say arm around each other's shoulder, and you walk 5 steps, 5 steps, 5 steps, 5 steps, you're always going to stay together. And that's kind of the way these lines are working. Okay, so the last example we're going to look at is obviously going to be one solution. So let's look at what happens when we do that. Okay, here we get a slope of 1 over 1 and a y-intercept of 3. Graphing that. Okay, start at 3, up 1 over 1. Okay, looking at the second example, again in standard form, we know that because they're standing next to each other. We're going to take the opposite of a over b, which is going to be negative 2 over positive 1. Okay, that simplifies out to negative 2 over 1, so I don't even have to do that. And then remember, for the y-intercept, we take this number divided by that number. There's nothing there, but there's really a hidden 1. So 9 divided by 1 is 9. Graphing that down to over 1. I get a line that obviously crosses 1 time. Okay, so what we're going to do now is we're going to fill out, in your notes, you should already have this, but you're going to have this blank paper. And what we're going to do is we're going to fill out the notes to kind of give us the solutions here. And what this is going to do for us is it's going to tell us, what we're going to do here is we're going to fill this out. And what it's going to do is it's just going to be a quick reference to tell us how many different possibilities there are. So first of all, when you have one solution, the slopes are different. Remember, the slopes mean the tilt. 2 lines tilted differently will cross 1 time. That's a fact, every single time. The y-intercepts, it actually doesn't matter where the y-intercepts are, because as long as the lines are tilted, they're going to cross 1 time. Okay, and we'll look later what happens when you solve them, but if you try to solve these problems, you're just going to get x equals 5 or y equals 2. You're going to get a normal answer. It's the other ones that you don't really get a normal answer. Okay, when you have no solution, you have the same slope. Okay, because no solution means parallel lines, lines that don't cross. So they're going to have the same tilt. Parallel lines always have the same tilt, but they're in different places. Okay, different locations. When you try to solve something with no solution, you're going to get something really weird, like impossible. It's going to be like 5 equals 10 or 0 equals 3. That'll be a clue that you have it, but our goal is to not have to solve it. Because if something has no solution, why would you solve it? Right? I mean, you can't solve something with no solution. So we're going to be smart about it. We're going to check the slope, check the y-intercept, and we're going to know ahead of time. For infinitely many, remember, that means the lines are the same. So they're going to have everything the same. When there's only 2 things that make up a line, if both things are the same, it's got to be the same line. What happens when you use a problem like that is you end up with something like 6 equals 6 or 10 equals 10 or 5 equals 5, something that's always true. The problem is these 2 situations right here, kind of confusing. You're going to forget what that means. So that's why we want to focus on first getting our answer using only these bits of information right here. In fact, I don't even need that. So really, when I take my slope, if I see it's different, bam, one solution. Okay? If I see the slopes are the same, I know it's either that or that, and I got to figure out which one. Then I check my slopes. If the slopes are the same, it must be infinitely many. And then I would say, it's not no solution. If the slopes are different, then I'd say, it's not infinitely many. Okay? So that's the way that So that's how we figure out the number of solutions. There's going to be a little quick thing below for you to fill out so you can make sure you understand it. Definitely go back through the examples if you need to. We're going to be practicing in class very, very often, of course. But this is one of the most important things you're going to learn in algebra. So it's something you need to make sure you understand and make sure you master. So go ahead and do that for 'em. I'll see you next time.